So a couple examples of finding a coordinate of a point given a certain transformation. So here's a couple of examples with a couple of points. So for this first one, grab a different color. For the first one, we have a point 2, 5, and we're going to transform the function by f of x minus 4. Now graphically, that moves the graph to the right 4. So if we look at our coordinate point, which is the point 2, 5, anything inside the function value will affect and change the x value. Anything on the outside of the function will affect the y value. So if we need this point to move right 4 graphically, then we'll take the coordinate point that we were given, 2, 5, and we'll move the x value to the right 4 units. So if you could imagine that, on a number line, taking the number 2 and moving it right 4, your new point would be the number 6 with a 5. So we take the 2 and move it to the right 4, which is a positive direction. So our new point is now 6, 5. Okay. For part B, you have a function, and then the subtraction of 4 is on the outside, and it's going to vertically shift the function down 4 units. So on our point 2, 5, it's going to affect the y coordinate, because anything done to the outside of a function will affect and change the y value. So if we leave the 2 where it's at, and then again, if you can imagine that point, 2, 5, and we're just going to move it down 4 units, we're just going to end up subtracting 4 from the y coordinate, and our new point is now 2, 1. All right. For part C, the 4 multiplied on the inside is going to be a horizontal change. Stretch or compression because it's being multiplied. The fact that it's the number 4, it's going to be a horizontal compression where whatever the graph looks like, it moves it in closer to each other horizontally. Because it's inside, it's going to end up changing the x value, but also because it's inside, it's a horizontal compression by a factor of 1/4, which means we will 1/4 the x value in the coordinate that we started with, 2, 5. So we're only changing the x coordinate here, and we're going to 1/4 it. So if I take 2 and multiply it by 1/4, I get 2 over 4, which is 1/2. So our new coordinate point here is 1/2, 5. Wherever that point was at 2, 5, we smushed it in closer together, so we quartered it instead of 4 in it, and now it's at the point 1/2, 5. For this last one in this example, the 4 is being multiplied outside, so that's going to be a vertical change. Again, anything that happens on the outside of the function is going to affect the y value because it's a function value. So this ends up being a vertical stretch by a factor of 4. It will actually 4 times a number. And if we have our original point 2, 5, again, because it's on the outside of the function, it's going to affect the y coordinate. And in this case, it will multiply times 4. So your new point is now 2, and that y value has been stretched up to the number 20. Okay. So here's another example with a negative in the coordinate point. I thought maybe that would somehow make it more difficult. So we have the point -3, 4. That's our starting point. And for the g of x function, we are going to take and do g of 1/3 x. Okay, again, because it's inside, it's going to be a change on the x value. The 1/3 on the x is a horizontal stretch So it stretches it out horizontally, this way, but it's by a factor of 3. We always do the reciprocal if the number is multiplied on the inside of the quantity. So in this case, when we start with our point -3, 4, again, it's a horizontal stretch. We're affecting the inside, so it's only going to change the x-coordinate, and it's going to get stretched by a factor of 3, so we'll multiply it by a factor of 3, and our new point is -9, 4. For part B, the 1/3 is multiplied on the outside, so we're now looking at a vertical compression. Okay, it takes the function and it sort of compresses it vertically, kind of flattens it, and we're going to do a vertical compression by a factor of 1/3, because anything outside does what it looks like it does. So outside will be a change on the y value. So our starting point of -3, 4, we're going to take that factor of 1/3, and then we're going to 1/3 the function value. So we're going to times this by 1/3. So our new point is -3 and then 4/3. Right. For part C, we have a -3x on the inside. So the fact that we have the 3 makes it a horizontal compression, but also because it's on the inside, it's going to be by a factor of 1/3. So it's a horizontal compression factor of 1/3, and it's also a reflection over the y-axis, which again, if you could imagine the graph, our point was at -3, 4, and we're going to reflect it over the y-axis. So now it's going to be over here somewhere. And then we're going to end up compressing it in this way together. So we'll do the original point of -3, 4, and if we compress it by a factor of 1/3, that turns it into the point -1, 4. But because we need it to reflect over that y-axis and have that happen with those points, we're going to negate the x value because we have this negative on the inside here. We negate the x value again. Anything inside affects x values. So our new point is now +1, 4. So it's reflected it over the y-axis, and then it has compressed it in horizontally. So that's your new point is 1, 4. For the last one, two things are going on here. Let's start on the inside. So it first has a horizontal compression by a factor of 1/3, again, like we just saw in the previous example. And then we also have this negative on the outside that's going to reflect over the x-axis. But all it's really going to do point-wise is it's just going to negate or change the sign on the function value, so on the y-coordinate. That's all that's going to do. So if we start with our point, -3, -4, nope, not -4, +4, and we do the horizontal compression first, that will multiply 1/3 to the x value, which will give us the point -1, 4. And then if we apply the negative on the function, we'll negate the y value, because again, anything outside is actually on the function value, which is the y-coordinate, and it'll turn our +4 into a -4. So our new point for -g of 3x is -1, -4.